The K-12 Engineering Education Podcast is made possible by pledges from individual listeners, including Jaime J. Lara. He's pledging to the show at the engineer level on Patreon, covering streaming expenses so that you, yes you, can listen right now. So thank you to all the donors, and especially to Jaime. Help us keep up the podcast by pledging to my studio at www.patreon.com/PiosLabs. It's April 17th, 2017. This is the K-12 Engineering Education Podcast. I'm your host and resident engineer, Pius. As always, thanks for tuning in, subscribing, and sending me comments about the show. Today's guest is Titus Wong, a pilot in training for the Air Force who also studied aerospace engineering in college. In this interview, Titus talks about how studying engineering helps him be a better pilot, and how teachers helped him stick with it even when the math was difficult. So the reason why you're on this episode is because we're going to talk about aerospace engineering a little bit, and also how it applies to your job. Can you describe a little bit what you do and what you've been doing?
I am a captain in the United States Air Force, and I am currently a pilot going through fighter pilot training here.
And as a pilot, do you think that your engineering education has come in handy?
Yes, but not in the sense that most people think. It's not doing mathematical formulas, or you're not doing derivatives, you're not doing integrals, you're not doing that high complex level of math where you need like a calculator or something like that. What you're actually doing is taking all the basic science concepts that you learned in engineering, and you actually will use it as a pilot. Because in order to be a good pilot and a military pilot, you have to understand the science behind what it is you're doing in an airplane. That's what makes you better at your job. By knowing the science, you'll understand why pushing your left hand forward and pulling your right hand back will make you go higher in the airplane without losing airspeed. Something as simple as that will help you understand.
So you're telling me that you have been learning how to be a pilot with a whole bunch of other trainees, right?
Yes.
And so how many of those people have the same kind of education that you do?
All of us are military officers, except for international friends who don't have to go to universities. Right. But of the Americans, we had 20 Americans in my graduating class, and of those Americans, only about half of them had engineering degrees. The other half had things as simple as business, and in one case, one of them had a history degree. So it's obviously not required to become an excellent pilot to have an engineering background.
So why do people get an engineering degree? And by the way, are they all aerospace engineers?
No, we have systems engineers, computer science, mechanical engineering, aerospace engineering, environmental, biomedical sciences. So it's not all physics related. There's definitely chemistry involved and biology involved. So it's not just one field of engineering. And we also have one of our graduates is also graduated in mathematics. So
how do these other degrees help them become pilots?
A lot of it, especially in flying an airplane, you can't learn how to fly an airplane without using math. And the math is all about the physics of how an airplane flies. It's, for example, using a flaps on the airplane, it changes the airfoil and ultimately the lift characteristics of your airplane. So you can now stay in the air at a slower airspeed and also have a steeper angle of attack, so you can make steeper angles of descent without stalling your airplane, or another case is like trying to grease the landing so you're not slamming into the ground. From the very basic, broad operating, like this exact moment, everyday flying, you're not thinking about that. But what engineering has done is, like, as you were learning about how these things worked, I was able to see all the aeronautical diagrams, all the curves that you see, your lift and drag diagrams, the mathematical formulas. They say, hey, this is why what you were doing or how it works. Like, I was able to see that and understand it immediately and grasp the understandings, whereas one of my business major colleagues had no idea what these graphs were saying. He just knows if I pull this lever and put the throttle at this position, this is what happens. So it actually ended up having, for him, things were coming very slow, whereas for me, things came really quickly as understanding why.
So there's a lot of mental work that you're doing when you're trying to learn how to be a pilot too.
Yes, like there's a lot of the times when you're like, oh, I pushed the left rudder in and my airplane was going left, but then it started doing this other spinning motion. Like, why did that happen? Ultimately, you can just do it over and over again. And it's like, okay, if I push my left foot down, then I'm going to start yawing to the left and start spinning left. But why does that happen? The engineering background helps explain that for me. It's like, oh, okay, that's what I did to the wings. This is what I did to the lift and the aerodynamic flow over the wing. And so you have a better understanding. Okay, now I know the academic side of it. Now I actually go out there and fly and actually do it. All that academic I had on the ground just kind of comes back to you. How would I say it? Comes full circle now. It's like, okay, this is what I learned, and I've actually seen it now because I know the science behind it, and I know physically the mechanical motions myself. I can now make a very calculated, precise movement with my body to do this in order to make the airplane do it exactly what I want. Whereas if I didn't have those understandings, I just knew this, this, I would never come to that conclusion on the spot. I would have to go through trials and error. In the Air Force, we deal with a lot of, especially particularly in the fighter pilot world, you end up doing a lot of stuff with energy diagrams and learning about energy. Ultimately, it comes down to like energy. So we're talking like kinetic energy, potential energy, and power.
So, like, by energy diagram, you mean like the diagrams you see in your physics classes in high school?
Way more complex, involving like G's and airspeed and power levels based on airplanes. Because we use those things to help compare ourselves to other airplanes, so that if we eventually, obviously, we're using these airplanes to fight, we want to know how we're going to go up against another guy. Well, you can just say you're better than one other person, but when you actually put the numbers against each other, you can clearly see, oh, if I do this at this rate, if I'm at this airspeed pulling this level number of G's, this is what I need to maintain in order to make sure I can turn faster than this guy. And if I get slow in a fight, I want to get out of that slow range and get to my fast range because I know my opponent works very well at a slower airspeed. So for somebody who doesn't have a science background and they see all these mathematical diagrams and the formulas and they're like, what does this all mean? Mm-hmm. It takes the experts who've studied this. Some of them are engineers who've studied this and it comes naturally. Others who weren't engineers who would have to spend weeks trying to fully figure it out.
Right.
It takes longer for these people who don't have science backgrounds to understand these things. Eventually they'll get it, and by all means, some of them are phenomenal pilots, but it just takes it longer and harder to fully grasp what's actually happening.
It sounds like a lot of what you're saying is the strategy of flying once you're up in the air. Like, granted, there's this physical skill and mental skill of flying when you're in there, but also you were talking about knowing stuff about the planes that you're flying against or your plane versus other planes and understanding all of that stuff. That's where your engineering degree helps out a bit.
Right, because it gives you that broad science background knowing, okay, I know what the diagrams are, I know what the mathematics is. If at these areas, this is what happens. So whenever I actually encounter them actually in the air, oh, this is what's going on. Okay, I need to do this maneuver, or I need to put the aircraft in this position at this power setting in order to achieve the desired outcome. Whereas if I didn't have those backgrounds, oh, I'm just doing it because I knew in the past this didn't work, so I'm just going to do this again. Or because people told me do this, so I do it. Granted, you can totally fly an airplane like that, but you're going to come in situations where you've never really seen it before. And if you don't have that academic background, the science behind it'll take longer for you to come to the conclusion of what you need to do.
It'd be like magic, I would assume, because there's no explanation for why things are. You just fly, and that's it.
For guys who don't have science background, they literally say it. Yeah, it's like they don't know why it flies. It's just like pure magic.
Right. Like when you drive a car as a kid and nobody tells you why.
It just does, yeah. Whereas if you had a science background, you understand, oh, this is why it's happening. So.
All right, well, talk a little bit about your engineering background. Did you see any of this stuff that you're seeing now back when you were studying engineering?
Yes. As a pilot, yes, you will see the basic, this is the drag formula, this is the lift formula, this is the thrust formula, this is your coefficient of lift, this is the lift versus drag diagrams. You're going to see all that. And then you're going to see more, like I said, the energy diagram. I never saw that, but that's comparing how an airplane performs against other airplanes. You usually don't see that in the civilian world, but when it comes to fighting, it's a game changer, like understanding how the science works. There's other things like the power curve when you're flying an airplane. at a certain point, if you get too slow, the amount of power you have at a certain configuration will never recover your airplane and you will fall out of the sky. So you have to do something to change it. I didn't understand that. It's actually one of the things I didn't learn about in aerospace engineering, but I learned as a pilot because like you need that more. So, but my science background, when I actually learned at the graphs and how it worked, it came really quickly. Whereas my non-science background, coworkers, it took them a long time. Like, why is that? I don't understand. I went to the University of Illinois at Urbana-Champaign, in Champaign, Urbana, Illinois.
Middle of the cornfields.
The cornfields, yep. Go Illini. I was a aerospace engineering in my bachelor's degree.
And so you did that for a couple of years, and then what did you do right after you graduated?
I went straight into the Air Force. Initially not as a pilot. I did the Air Force ROTC program at the University of Illinois. I got my commission in the Air Force, and then I actually started as a radar controller, where you really didn't use a lot of, in fact, I probably used zero of my aerospace engineering skills, actually, as a radar controller. I only started recently as a pilot, actually starting to actually use it now. And it actually helped reinforce those things that I learned back in engineering. It's like, oh, these are why the formulas work they are. This is like the aspect ratio, like why this airplane, like I understood, okay, this is why it works, but you don't really quite understand that you actually go up an airplane and physically control it. They're like, oh, okay, that's now I get it. So
would you say that your undergrad degree, I mean, it helped you become an officer, but did it help you get into doing like those radar missions and everything that you first started out with when you went into the Air Force?
No. What the undergraduate degree for me was it's basically the key to get a commission in the military. That was really what it was. But along those lines, I wanted to study something that interested me to help as I got to that direction. So that's why I chose aerospace engineering, because I knew I wanted to do something with airplanes. I knew I wanted to, understand why things were. So in case I never got in the Air Force, at least I can build airplanes, you know.
Are you still interested in the design aspects of flying?
Now that I'm actually flying, probably not so as much because flying is more fun
than sitting at a computer and designing stuff?
Yes. But I would definitely say if I were to help, I would definitely help design an airplane as the operator now. This is actually one of the things the Air Force does is actually when they have test pilots, every time the Air Force develops a new airplane, it has test pilots that are Air Force pilots, and each one of those test pilots have master's degrees in some form of engineering, whether it be mechanical.
Really?
Yes, and all their test pilots have to be pilots with master's degrees in science. So it's mechanical engineering, physics, mathematics, aerospace engineering, electrical engineering, something like that. And they're the ones who are help giving the direct feedback to guys at Boeing, Lockheed Martin, General Dynamics, Northrop Grumman. They're the ones who are giving the feedback. Hey, this is what happens when I do this. I know this was what you guys told me, but here's what's actually happening. And they can use their knowledge of the science and give the feedback to the engineers like, hey, this is what's going on. You need to fix this. Or, hey, this worked extremely well when I did these things. So obviously you can have all the math in the world, which should say one result, but obviously now that the pilot, he's going to go out there and confirm that that's exactly what's happening, and or otherwise, like, oh, disprove it, like, hey, no, this is what really happened. So the math model was slightly off. So okay, and now they can make their adjustments. So, in that sense, the engineering is vital to how the development of future fighter aircraft will be for the U.S. military.
So then when you're done with your flying career, years from now, you technically have the option to go into one of these other companies to help them design stuff and test things?
Technically, yes, but not as the off-the-wall, off-the-street, engineer. I would more than likely not be the one who's going to go into MATLAB and start programming code for the next stability control thing. I more than likely wouldn't be that guy running, the wind tunnels. I obviously, because I've been so far out of it. But what I would be, should I decide to do something like that, is I'd be the liaison to give the engineers who've never actually flown an airplane, this is what's actually happening in the pilot when he's thinking, or this is the feedback you get, or this is how the airplane is actually performing. So obviously, like, most of those engineers never actually go in the airplane they design. So they never truly understand what it is they're building. Yes, they see the numbers. Yes, they know it should do this, but they never fully understand it. And that's where the pilot who has the science background, he can talk to them at that technical level language. Hey, this is what was happening as I was doing it. And this is, you guys claimed it to be this, but this is what it's actually happening. And here's my probable analysis of why. And they can help make that optimize the system, if you will.
So a lot of teachers in high school or in junior high and elementary school might be listening. If they've got kids in their classes who are interested in aerospace engineering, what would you encourage these teachers to do to help foster their interest?
Obviously, aerospace engineering encompasses large areas of field of study. It's not just airplanes. It could be space. It could be rockets. It could be control systems, fluid mechanics, aerodynamics. So obviously, there's a whole plethora of areas of science that it's not just an airplane. What I would suggest, and this is the one thing that no fault to the University of Illinois, their aerospace engineering program is highly theoretical. So I would say a good 90% of all my classes was theory, math theory.
You were in school like more than 10 years ago.
I graduated back in 2007.
Right.
So almost 10 years ago.
Yeah, so hopefully the education is a little different today, but I bet a lot of it is the same.
My understanding is after talking to several aerospace engineering graduates from different universities, yes, it's highly theoretical.
Okay.
As expected, actually, from a prestigious engineering university. But at the high school level, what I would say is what would get students to this level is show them the end product of what it is aerospace engineering would give. Build gliders, bring them out to airplanes, send them out to areas where they can physically experience the end result of the engineering. We see it every day in computer science, like iPads, iTouches, cell phones, Xboxes, PlayStations. We see that end product every day. In aerospace engineering, we see it because we see private airplanes, Cessna's flying by, or like jumping on a Boeing 747. But they need more exposure to that. They need to go expose them to like the everyday. Here's an airplane. Here's a golf ball. There's a dimples on the golf ball for a reason. They need to get these kids experience the end product of the science, and then from there draw them back
into the theory.
That's the way you're going to get people interested in aerospace engineering. And they do. You see that a lot actually in aerospace summer camps. A lot of aerospace summer camps, like they always have like the rocket launch, little plastic model rocket with those like basically firecracker engines, and you just shoot up in the sky and open a parachute. Cool. Like that's the kind of stuff that's what's really going to get them into engineering. But if you really want to get them further and deeper, you got to build on that. You can't just do that one thing. You actually have to like take them into a flight, or obviously that would be really hard, or like a glider. Those things obviously cost money or something, but right. Show them the videos. Like you got to show them what worked really well for me. I was like, of all the math classes I had in college, like here's the math about, okay, here's the math behind the physics of what's going on. Great. To me, all that stuff is just a bunch of letters and numbers and formulas and stuff. But what helped me was like, okay, now one of my professors like, all right, we've done that. Here's a video now of exactly what I'm showing you. And here's exactly what's going on. So now I got to see all the math. And now I actually got to see the actual video of like, that's what the math actually means. Oh, okay. They need to draw that kind of stuff, those kind of connections. And at the high school level, it doesn't have to be airplanes. You can do it with cars, like I said. You can do it with skateboards. You can do it with cars. You can do it, bikes, your helmets,
like anything with aerodynamics.
Anything aerodynamic related, which is pretty much everything.
Or fluid.
Or any kind of fluid dynamics, yeah. Even structural science, like a lot of aerospace engineering has to deal with material science. Simple, like taking balsa wood, taking styrofoam, taking pieces of metal and just showing, hey, this is what happens when you deform it and put it under pressures. Like, look at this. And then you can throw a little math formula. This is what you're seeing, this bend here is this math formula. And then, but make it interesting for the students. Don't just make it like bend a piece of metal. You gotta relate it to the things that students see every day, like their chair. Probably made out of steel. Cool. Here's an example of that steel bar you had that the student is sitting at, and you break it. You want, like, this is how much force it's gotta be equal to. One of my high school physics teachers explained, when I had this question, I asked him, hey, what exactly is 100 newtons of force equivalent to? So, and he didn't understand my question. Well, I could say, like, I know what 100 pounds of force is like. It's like me pushing myself up or me falling at this X distance. But what is 100 newtons actually? And he's like, well, imagine taking like a 10 kilogram baby and me throwing it in your face. That's what 100 newtons of force would feel like. Oh, okay.
Nice.
totally weird for the general thing, but hey,
you remembered it.
I remember that because it brought the science to something that I could relate to.
What would you do different, if anything, if like you had to do your education all over again since you were a little kid? Is there anything you would do over, or pretty much everything was pretty golden?
I don't know. There's multiple ways of getting to the path that I came to.
Yeah.
I was never strong in math, and here's another thing for to teachers out there. I was never strong in math to begin with. The only reason why I powered through all the math and stuff is because I really liked the airplane. I really thought it was cool to see how it operated. So I had something was motivating me. It was the end product there. It was motivating me to go. So I don't know if I'd do anything different because there's so many different ways, and it's really difficult to say for me to what would have been better.
Yeah.
Probably studying math more. Probably.
That's fair enough.
But I mean, there needs to be something that'll motivate the student to continue in that realm because it's very, very, very discouraging. The world of mathematics and science is very discouraging if you don't get it. And it's very easy to quit because it's difficult. And some things take extremely long time to understand for certain people, and others comes really easy for them. So for those where it comes really difficult to understand, they need something that'll help drive them to continue to study it, whether it be money, financial reasons, or whether it be solely purely just the development of sciences or for whatever cause for humanity, or just developing the field of technology. Something's got to keep them motivated, and that'll be the breaker, or the breaking point for students if they want to continue in aerospace engineering, for example.
And then finally, do you know if, in your experience, does the Air Force want engineers for any particular reason?
Yes. My understanding is the Air Force has always been desiring to get engineers. For example, the Air Force Academy, they have multiple fields of study, but majority of the students that come out of there have a science degree, because the Air Force is a culture of science and technology. It leads the fight through innovation and technology. And I'm not saying that just because that's what the Air Force advertises itself as, but if you look at all the other services and look at all of our Gucci toys, we seriously have the top of the line world of technology stuff because we have science everywhere. They want that technical background. That's what they're looking for. They want the technical background because a lot of things the Air Force does is technical related. There's a lot of science and technology behind it, and they want people with that background of understanding so that they can better operate what it is they're doing. And at the same time, they're grooming them to become managers and leaders. So there's a whole other world that they're teaching you in addition to just science and math.
Do you know anyone whose career was influenced by studying engineering? Let me know. You can tweet the show's Twitter at K12Engineering or tweet me at Pius Wong. Subscribe to and share the show on iTunes, SoundCloud, Stitcher, or your favorite podcast player, and give us your reviews and stars too. That'll help others find the show and join the discussion. Get the latest show links and info at the podcast website, www.k12engineering.net. Our closing music is from Late for School by Bleep Tour under a Creative Commons Attribution license. The K-12 Engineering Education Podcast is a production of Pios Labs, and you can support Pios Labs at www.patreon.com/Pios Labs. Another new update from your nerdy host, Pius. This update is about a new little business initiative that I'm scoping out, and it's related to that book and that workshop that I've mentioned before, too. Remember, my book is called Engineer's Guide to Improv and Art Games, and people can find it publicly off Amazon and a bunch of other places. And that workshop I did was with my colleague, Rachel Farrig. We both went to South by Southwest back in March, and we ran this workshop with 40 different engineers and developers and designers and artists, and we taught them how to play some improv games and theater games and drawing games, and coupled that with research-based design methods like brainstorming or something called C-sketching. And it was really cool. I got great feedback. The games helped people get into the flow of these different design techniques. If you're interested in taking a workshop like that, I am asking you to just let me know. I'm doing some market research essentially. Just send me an email at info@k12engineering.net or contact me some other way and say, hey, I'm an educator, or hey, I'm a mechanical engineer, and that workshop sounds cool. If enough people contact me, that'll help me tailor that workshop towards specific audiences. You don't even have to be around Austin, Texas. Just let me know if it sounds interesting to you or your organization. That is it, and I'll keep you updated. Thanks.